Saxon's Trig, lesson 11, continuing. I did not finish the examples from section 2 in the other video, so I'm picking up with example 2 on page 86. We have a circle and a polygon inscribed in it. This one is labeled 75. This is the Y. This is X, and this is labeled 80. Since this is a polygon inside of a circle, the rule I want to remember is that the sum of the two are going to equal 180. So I can say Y plus 75 is 180, and I can say that X plus 80 is 180. Minusing the 80X is 100. And Y minusing the 75 would be 105. That is a quick and easy one as long as you remember the rule. Example 3 has a circle with a triangle inscribed in it. This is 35. This is 75. This arc is labeled Y, this arc is X, and this one is Z. And the question asks to solve for X, Y, and Z. This is where we go back to inscribed angles and the arc that they cut. So if this is 75, X must be double that at 100 and... why I'm having trouble there, should be 150, yes, okay. Then Y is cut by this angle 35, so Y will be doubled to 70, and then Z, they did not have a number opposite this one, but I can find what it is because it's in a triangle, and every triangle is worth 180, so you're gonna minus 75 plus 35, I believe that's 100. That minus would be 80. So if this is 80, then this would be doubling to Z is 100 and... Uh-oh, I've calculated wrong because it says Z should be 140. The other way that I can do that is to say 150 plus 70 and subtract that from 360 either way. So I'm gonna try to fix the one I have here. 5 and 5 was 10. Ooh, that was 11. There's my error. And then subtracting, that's 70. Yes. So the arc, the angle is 70, the arc is double to 140. Yes, that is correct. Oh, and these are definitely degrees because they are the arcs. All right. Example 4. This one has two chords crossing, 15, X plus 10, 20, and X plus 5. So I know that the chord lengths must be the same, which means 15 times the X plus 10 must be the same as 20 times the X plus 5. So now we're going to distribute 15X plus 150 equals 20X plus 100. Like terms, if I move the 15 over, I avoid getting a negative, so minus 15 leaves me 5X. That means I will definitely minus the 100 and get 50, and then X will be 50 divided by 5 at 10. And all it wanted was for me to find the X value. Example 5. We have a circle, and we have a series of, oops, that didn't draw to a tangent very well. So now the circle is inscribed inside of the triangle. They've labeled this X plus 4, this one X plus Y, this one is 10, this one is X, this one is X, and this one is 6. So I remember that my tangent lines have to be the same. So from this tangent spot and this tangent spot to this connector, they are both labeled X. Doesn't help me solve for it, but it is part of this pattern. So if this one is 10, that should match with the X plus Y. And then if this one is 6, it should match with the X plus 4. I can solve this one here for the X by subtracting 4 and getting 2 and substituting that in. So 10 equals 2 plus Y, minusing the 2 solves for the Y. That gives us 8. And we already knew that those were 2 and 2. Then if we plug it in, the question just asked to solve for X and Y, and we have accomplished that. Yeah, just double checking that answer. All right, I think I can go ahead and fit it in here. We did, in an earlier lesson, completing the square, and just to review, those steps were half it, the X term, square that, and add it to the other side, and then you have the ability to solve for X. There is a shortcut that rather than having to complete the square for every single problem, we memorize the quadratic formula. And hopefully you remember it from Algebra 2, but if not, here it is. And you will definitely memorize it because you will hear it many, many, many times. So it says negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. And where do these a, b, and c things come from? So whatever number is with your x squared, that's your a. Whatever number is with your x term is your b. Whatever number doesn't have is your C, and the problem should always equal 0 before you attempt to do the quadratic formula. In example 6, they say use this formula to find the answer to this problem, which is 3x squared minus 2x plus 5 equals 0. So our A is going to be 3, B is the negative 2, and C is the 5, and we're going to fill into the formula. So x equals negative 2 is 2, plus and minus the square root of negative 2 squared to 4, minus 4 times 3 times 5 all over 2 times 3. All right, so 12 times 5 being 60, 4 minus 60 is going to give you a negative 56 inside the square root. If you can split that up, do that. I know that 2 will go in 48 times 2. Go ahead and do that to a 4. 4 and 12, 2 and 6. That's a lot of splitting up. And then our 4 splits into 2 and 2. So how many? Obviously this one's going to be a set. There's a set 2 here, and that would have split to 2 and 3, which doesn't have a pair. So we're pulling a 2 out and a 2 out, which makes a 4 on the outside and a root 6 stuck inside. I know I'm kind of cramming things everywhere around here, but to give you then x equals 2 plus and minus 4 root 6 all over 6. And will your 2, 4, and 6 reduce? Yes. They will go down to a 1. This will reduce to a 3, and this will reduce to a 2. So my final answer ends up being x equals 1 plus and minus 2 root 6. Oh, I'm not matching their answer key. All over 3. I failed to deal with my negative here. When I have the negative, I'm definitely pulling an I out. So this will have an I attached with it, and technically it should be in front. It's just easier to make it not look like the I is in the radical. Did I split that wrong? Nope, negative 50. Okay, so negative 56 was right. It is somewhere in my split. It's because this was so messy. 2, 28. 2 and 14. Oh boy, okay, let's do this up here. 56, 2 and 28, 2 and 14, 2 and 7. Ha ha ha, okay. One set 2 makes this 2, so when this reduces, it also goes to a 1. This got stuck as the 2 and 7, 14 that I could not change. Okay. I hate to write it in another crammed in spot, but this is so messy. I just want to make sure you know exactly what that final answer should be. So x equals 1 plus and minus the I square root of 14 all over top of the reduced 3. Now am I, okay, and they put their I at the end. I prefer it in front. That's just a mathematical preference on my point to avoid confusion, but this is the final answer that you're actually looking for in completing the square. When you do the completing the square, if the factoring would not have come out nice, like been able to put it into 2 parentheses to factor it, your quadratic formula will always give you messy looking answers, because it's messy because you can't factor it into the 2 parentheses and get a nice answer. So you are expecting something that is that way.